Good morning, everyone. We'll be getting started here in just a moment. Welcome. We're so excited to have you here with us today. It's going to be a really exciting session today for our fall learning series. We have two of our leading professional services data visualization architects, Ying Wang and Ian Liao, who are going to be taking us through an exciting topic today, super advanced author workshop. Essentially, we're going to take you through a series of activities that will really go above and beyond what you've seen in other introductory sessions. We're going to be doing things like nested aggregations and calculations, numeric filters, segmentation, etc. Just wanted to kind of make sure that you're in the right place. Hopefully you have some prior experience authoring with QuickSight. We will be expecting that the activities today would be done within a QuickSight enterprise account. And if you're going to be doing hands-on activities with us, you'll want author privileges. We are going to demonstrate some things that if you were going to try and follow along, you would need admin permission as well for user and group management and CLI and API access. This is really optional because we'll show you, you don't have to follow along with that activity, but I did want to just call that out if you'd like to get that in place while we're getting started here. That would be an optional segment there. Just kind of covering a couple of key details before we jump in with the content. One of the things that we think is an important component of doing these sessions live with our experts on the line is to get your questions answered while you're doing the hands-on activities. So within GoToWebinar, there's an area on the right-hand side of your screen. It's a little panel, and you can post questions about the content or flow that we have here. We will not be saving or sharing the questions and answers after the event. So if you do have a question that we give you an answer to, make sure that cut and paste it if you want to look at it again. Just for future reference, we do have a QuickSight community that is available for getting questions posted and responded to from the community. In a few weeks, you'll see some nice enhancements to that community. So looking forward to continuing to engage with you for Q&A after today. We will be recording the session today and posting this via our QuickSight YouTube channel by the end of the week. And so just without further ado, I'm just going to share with you a link here, and we'll put this link into the chat window as well. But the content that we'll be accessing, this is a public website, or it's publicly available. You will need the username and password that we have here. And without further ado, I'll go ahead and turn over presentation privileges to Ian, who will get us started with the first activities. Give me just 1 second.
Nice.
All right, take it away, Ian.
All right, thank you. Thank you, Q. All right, hey guys, thanks for joining us, and also thanks for having me here. So welcome to the super advanced author workshop. Don't feel intimidated by the name. So in this workshop, we'll just talk about QuickSight calculations and filters. What we are going to do is we're using the basic techniques in QuickSight that's been discussed in previous workshops. And we want to use that to build some interesting use cases. So probably it's going to be like a combination of a few techniques that you have learned from in the past. And you will see how amazing QuickSight is. It can really build some use cases that you never think of. For now, I think Gil has shared the access to a public available embedded QuickSight page, embedded QuickSight dashboard with you. So if you go ahead and log in to that page, you will see the content, the same dashboard that I'm showing here. I hope that'll be helpful for you to kind of learn learn what the use cases are. And we also in future we also plan to update this dashboard and also sharing a public QuickSight template with all of you, and also the color formation template. So with that, you will be able to actually not just see the dashboard, but you will be able to download, kind of copy this dashboard into your own QuickSight account, and you will be able to see how these use cases are built. Yeah, with that, let me introduce the content developer of this workshop a little bit. So we have a team of 3 ProServe consultants who works on QuickSight. We have Guinea, Malik, EM, Liao, which is myself, and Ying Wang. And we 3 work together to develop this dashboard, these use cases. Guinea is not available today, so I will cover her part. And we'll talk about roughly 8-9 use cases. We'll talk about advanced numeric filter. We'll count advanced some use cases of parameter. We'll talk about using level-aware aggregation for nested aggregation. We'll talk about segmentation and also like single selection set qualification. And then Ying will talk about some like multiple selection set qualification and like very creative, like comprehensive and all operators in filter, and then advanced security filters and also push down calculations into the ETL process. Before I get started to the first use case, I want to walk you through a little bit on how to set up the data set for the whole workshop. So we have a link here that's available in the dashboard we shared. So we are using a data set that contains like over 100 years of Olympic history data. You can just click the link. This data set is actually on Kaggle. So you can click this link and you can just scroll down and download the first athletic event.csv file. So this will be a data set we use for the first like 6 use cases. Yeah, and then for the last 1, 2, 3, 4 use cases, it's a little bit more complicated. So we will have some ETL process and also some like API setup to set up QuickSight group and users. So we don't really expect you to follow that within the time of the workshop, but we will provide more details and so that you can learn after the workshop. All right, is everything good?
I think we're good.
All right, so with that, I will continue to our first use case. By the way, so downloading the data, it should be straightforward. So you just click on the link here and then upload the CSV into your upload that into your SPICE data set. So I'm not going to show that, but I'll just continue to our first use case. So in the first advanced numerical filter use case, we want to discuss a few techniques that we want to use. In QuickSight, we can play with filtering. So the first use case is we want to sort the teams. Like in teams in this data set, it actually means countries and regions who participate in Olympics. So we kind of want to sort the teams based on how many gold medals they have received over the history. And if there's a tie between 2 countries, we want to break down that by how many like total medals that the team have received in the history. So how are we going to do that? So for this use case, we have a building steps written on the right-hand side, which you can read. And I will just follow the building steps and show you how each of the steps are created. So the first thing we want to do is we want to create a numeric parameter, which is the number of teams we want to show in our visual, right? This is called we call it a top team parameter. And the data type of that is an integer. When you create a parameter, you can choose a data type between integer, string, date, and yeah, I think that's it. And then you can, sorry, decimal. There are 4 different types we can choose from. And then for this case, we are choosing a single value of parameter. We can set default value to be 5, which means we want to show top 5 teams by default. And the overall like output of this will look like if you set 8 teams here, you click enter. So we will show like 8 teams in our first visual. Right? If we reset, we'll show 5 teams. And then how do we count the number of medals? If we want to do a medal count for gold medals and as well as total medals, right? So that means we cannot just simply filter add a filter to medal of the whole visual, right? That means we will basically, if we say medal equals to gold, then we'll filter out all the record that's not gold in our use case. So how to do that? We want to do a count if. QuickSight provides a count if function that literally does the count only when the conditions are satisfied. So for the gold medal count, what we could do is we could do a count if on the ID of the on the ID column of the dataset, where the medal column equals to gold. So let me show you the calculated field definition. Count if of ID where medal equals to gold. So this will give us a count of the number of medals received by each team. Similarly, if we want to doing the total medal count, we're doing a count of ID where medal equals gold, or medal equals silver, or medal equals bronze, right? So that means it will basically doing a count when the player actually received the medal in that particular record. So with that, we will be able to have the gold medals and the total medals. And now, once we have the visual, we can put the team on it. We can put the gold medal count and total medal count on it. So if you expand the field well, you can see that since we are doing a count in our calculated field, which is already an aggregation function, right? So we don't have to specify another aggregation here. So here, the aggregation function will be a custom, which basically resumes the count if that we are using in the calculated field definition. And now we will now try to connect the visual with the parameter we created, right? To implement the top filter in our in which is our purpose. So we can create a filter called filter on team, because that's the dimension we want to filter on. We want to get the top teams out of the record, and we will use the top and the bottom filter, which is a filter type in QuickSight that allows you to filter on a particular dimension, and then but you can sort this dimension based on certain measures. So we want to show like the number of top teams, right? So this is here we are using the parameter. We're showing the top teams. Here we check the use parameter, so we can choose the numbers of the record we want to show in our visual. So I'm showing top teams. By is a sort by option. So we'll sort by the medal count, the gold medal count. And here we're choosing top, which means we are sorting from top to bottom, and we're choosing the top the top numbers, basically the teams with the most gold medals. And then here is a tiebreaker. So we can say if there's a tie, then we can add the total number of total medals as a type as a breaker, and we can sort that by descending order. Again, the aggregation will be custom because in this calculate field, we already have the aggregation function defined. So yeah, so with that, you can continue to add tiebreaker if necessary. In this case, it's very rare that we cannot break tie with two measures, with gold medal count and total medal count. So with that, let me disable it to show the effect of this filter before and after. So before we enable this filter, we are seeing like all the countries in our data sets, right? And I think we have sortings enabled, so that's why we're showing the total gold medal count on top for the first one, and then the total medal count. And then if we enable it, you can say that we will be only keep the top 5 record. And if we want to see like maybe 100 record here, the top 100 countries. And when we scroll down, when you have time, we'll be able to see that the record we kept will be, in this case, will be above, will be gold medal with 8. And the total medal, you can see the minimum number here is gonna be also 8, right? But there will be other, so those are the countries which has the, actually they're all, they get 8 medals, which means they are getting all the gold medals actually. So it seems we have another tie we didn't break in this case, likely. So let me try a different use case here. Maybe 200 top teams. Yeah, what I want to show is a tiebreaker effect. So let me see, 1, 2, 3, 4, 5, 10, 1, 85. Here you go. So you can see that for the top, for the last 3 countries or teams in this list, so they have received only 2, the 2 gold medals, right? And like you already seen, there are definitely more teams that has like received 2 gold medals. So to break tie for us, we're actually using the total medal count to pick the teams with the top number of total medals among those countries with just 2 gold medals, so that we keep the these 3 countries at the bottom of the list. Any questions so far?
I think we're good on questions so far.
Cool.
As a reminder to everyone, we are looking for your questions in the right side panel. There's a little gray area that you can post questions if you have them, and we've got a couple of folks trying to make sure we get as many of those answered as possible.
All right, so now let me set this back to like top 10 teams. And let's move on to the second use case. So in the second use case, we kind of want to compare the average age of teams of people who receives medals in different sports. So let me first disable this filter. And let me kind of resort it a little bit. So I think now we are sorting by age. Let me sort it by the sports first. Yeah. So now here we are showing two measures in this use case. We have average age by team, and we have the average age by word. So in this case, you can see that what I'm showing is, so for example, for the first measure, we're showing the average age of players who is in a particular team and who actually won like a bronze medal in wrestling. And the second measure we're showing is like the average of the players who won bronze medal in wrestling, and you can see that, so these numbers are the same for all the wrestling and bronze, right? And for the average by team, since we are reporting on the sports and medal team, these numbers are different per each record. So how do we build this like two level of information in the same visual? We're using a QuickSight technique called level-aware aggregation. So in our first measure, we have using a calculate field average age by team. So let me open that. And you can see that we are trying to do we're trying to do average over, and we are calculating the average over the age of the record in our data set. And the output level here is team and medal and sports, which is identical to the 3 dimensions that we have on the visual, right? And then we are doing pre-aggregation. So recall that what the pre-aggregation and the pre-filter is. So pre-aggregation and pre-filter are both calculated even before the aggregation is kicked in QuickSight calculation steps, right? And it will basically trying to do the over type of calculation on per record. Like you have 10 record in for the input, we will calculate the output of a 10 record as well. So so in this case, we will be for the first measure, we'll be calculating the average age per of each teams who break down by the sports, medal, and team. And then on the same visual, I mean, this is actually identical if we just use, in this case, in this particular use case, it's actually identical if we just put the age with average aggregation function here. But what we, on the right-hand side, how we want to calculate the average age across a word, right? How do we do that in the same visual? We define a similar average over calculate field, again on age, and we, in this case, our output level will be at the medal and sports level, which means it will basically doing the average over calculation to a higher level than what we want to show on the visual. Again, this is done even pre-filter, which means we'll ignore all the filters that's actually applied on the visual. And on the same time, it's pre-filter is also pre-aggregation, right? So which means this is calculate pre-aggregation. We are calculating the same number record within our data set, and it's just the data is being aggregated and duplicated for all the medal and sports group. So we can put these two calculations on the measure on our visual, and we'll be seeing that again. We haven't defined the aggregation function yet, right? Since the average over is a pre-aggregation calculation. So you want to specify aggregation function for these two measures. And since there are duplicate rows, right? I mean, the output level is already at higher or equal level of the visual level. So we would like to use mean as the aggregation function for these two measures, so that we are getting the mean of the average of different groups of record. So yeah, so with that, we can see the average age by team and average age across the world. And we're all looking at the sports and the medal breakdown. So now, remember, in the average age team by team, we are trying to calculate the pre-aggregation, and in the average age by word, we are using pre-filter. So if we are adding a filter on top of average age by team, let's say if we want to let me enable this one. And I will show you how this is defined. So if we want to try to find all the average age, or the team's average age is greater than 13 years old. So we will be defining a filter on top of the average age team calculate field. We use mean as again we use mean as aggregation function, and we'll say that is greater than 30. And you will see that on the right hand side, it will basically take away all the record under the column of the average age team. We will basically take away all the record that's below 30, right? But on the right hand side, for the average age word, since we have set it as a pre-filter, which means this calculation is not going to be affected by the filtering we put here, right? So we still see the average age of across world being below 30 in many use cases. So that what we have achieved here is basically we are using a level over aggregation to calculate different average to different perspective, right? And we are also on the left hand side we're applying a filter, but on the right hand side we kind of ignore that filter so that we calculate we're doing a calculation in different aspects. All right, so now let's move on to a third use case. In the third use case, what we want to show you is the kind of the similarity or difference when we define a calculator field with aggregation function. So we have put two measures on this visual. And about dimension, we just put team, as you can see. And the measure-wise, we put age, which is just one measure from the data set. And then we put the average age, which is basically doing average of age on the visual. And you can see that the calculation, just let me take one step back. So on the aggregation function wise, for the age, we're doing average. And for the value, we're just doing the custom because we already have aggregation function defined in our calculate field expression. Right, so you can see that the calculation of both two measures are actually identical, right? So that's because we are on the left-hand side, it's average of age, and right-hand side is also average age. So they are, they are defined in different format, different techniques, but the calculation is actually the same. So now let's check filter. So again, we can have an average age greater than 30. Let me display both of them first. So for the filter, let me first enable the one on the left. So this one is average, the age is greater than 30. So let me show you that is, we have in this case, we can allow you to specify, because we are defining a filter on top of a field that's from the data set, right? That's not a calculate field. So we allow you to specify if you want to apply a filter before aggregation or after aggregation. So in this case, we are applying this filter with no aggregation, which means it's before aggregation, and that is like basically this is applied on every individual record, right? So it's like in a where clause in your SQL query. So we are doing for each player who participate in Olympics, what is age at the time when they participate, and we are filtering out any age that's below 30. So once we enable that, you can see our average age actually went up, right? Let me try to show you again. Let me disable that. It's a lower age, and if we enable that, we are seeing the average is going up. So now let me disable that, and I'll show you the second one. In the second one, when we first enable that, there is no data. Why is there no data? Because normally, like younger people participate in Olympics, right? So in our filtering, we are trying to calculate, hey, what is the average age of the aggregated team level average that is greater than 30. So if we disable this filter, you can see that, I mean, for the aggregate level, like for the team average age, I mean, pretty much no team is above 30, right? In our case, so we do have another top team filter here, which we will show us top 10 teams in this case. So for this top teams, no one's average age is above 30, right? Does it mean like no players is above 30 in this all teams? Definitely not, right? So if we enable the first filter, it will show you like basically what is the average age of the of all the team of the players in these teams that their age is above 30, right? So that shows you like the elder player in Olympics and what are their average age. And now because this filter is enabled, and if we enable a second one, it will not be effective, right? Because we already calculating the average, which is above 30 already. Then if you do another filter on over 30, it will not do anything. Does that make sense? Yeah. So this use case basically what I'm trying to show is the difference between the filtering applied before aggregation and the filtering applied after aggregation. So if we do an analogy to SQL, it's like comparison between the filtering in where clause and the filter in the having clause. All right. So now let's move on to the second group of the use case, where we want to talk about parameters. We have talked about filter. Now let's talk about parameter. So we have two use cases here. The first one is so thinking like you may want to build some interactivity in your dashboard, right? You want the user to be able to kind of drill through one dimension to another. Well, there are, I mean, different ways to do that. You can enable draining, right? Or you can using this way allows you to using parameter and a control over the parameter to achieve a similar effect. So what we will do is we will first create a parameter, and it's a dimension filter. The name of the parameter is called dimension filter, and it's a string parameter. Again, single value, and the default value will be team. And then in our control, let's say you can choose a dimension. We use that as the name of the display of this control, and we allow user to choose between like team and sports. So the next step, we will create calculate field, which is called dim filter. And let me show you the definition of it. It will be basically if-else condition. So if the parameter we set is equals to team, then we will show the value of team column. Otherwise, we'll show the value of the sports column, right? So now let's just put the dim filter as dimension. In QuickSight, you are allowed to convert a column be back and forth between measure and dimension. So, and in this case, we are choosing the dim filter as a dimension. We can put that on the visual, and where you're using our like average age, like similar from the previous example, we're just doing average age here. So putting those two on this visual, and we can use this control to change the value of the dimension, right? So now we are doing team. We're showing the average age of teams, and we can switch that to sports. Yeah, so then basically we'll be showing the average age per sports. So what is done behind the skin? So like the calculate field will be the calculate field we call dim filter, dim underscore filter. That's just calculate at runtime, right? So at runtime, depending on the parameter value, we are setting its value to be either same as dim, same as a team column, or the same as a sports column, right? Then when we put that on the visual, it will basically, as a dimension, it will be doing an aggregation over it, right? We're using that as a group by, like in a group by in a circle. So that's why you see the average age a calculation and grouped by different dimension. And one trick here is on the I think on the group by column header. Here we can also refer to the parameter we choose. So that's why when you choose sports, here we say dimension sports. And if you choose team here, it shows dimension teams. All right. So similarly, we are kind of using parameter to operate the dimension. And similarly, we can also use parameter to like affect the measures. So in this case, let me show you the second use case. In the second use case, we want to kind of sort like teams or country or regions based on their medal count, right? Again, we have our total medals and the gold medals. These two measures are defined as we see in the previous example. And in some cases, like people are like to sort by like total medals, and in some cases, people like to sort by gold medals. So we can enable that by adding a sorting parameter and a control on top of it. And the definition of the parameter is let me see which one it is. It's a sort measure. Again, it's a string with a single value, and the default value of this parameter is called medal. And in the control, we can allow user to choose between gold and medal, right? If you choose gold, we will sort by gold first. Otherwise, we'll sort by medal first. Then we want to define another measure here, which we call it sorting. So in this measure, we basically depending on the sort measure, the parameter. If it's medal, we will give the value, give it the value of the total medal count. Otherwise, we'll give the this to be the value of the gold medal count. And so we can add the total medal count, total medal count, and also the sorting measure, all three of the three measures into the visual. And what I did was we could actually hide the sorting column here, right? So we can set the visual to be sorted by the sorting column, but we can hide it from the visual. So if I do show, you can see it here, and if you do a hide, it's gone. And now with the control here, you can switch between sorting method. You can switch between sorting by gold. You can see in this case, I think we do have some filters, some other filters to make a meaningful data. Yeah, so we are just doing the year of 2016 Olympics. So by gold, you can see that Great Britain is the second of the list, right? And I think the German, Russia will be a third, and German will be a fourth. So, but if we switch to the medal count, using the medal count as a sorting method, so Germany will be the second, and Great Britain third, and Russia will be the fourth. Yeah, so that's a way to enable different sorting on a visual through the parameter and the controls. I mean, well, like I think this is more for these two use cases are more for like user experience, because like of course you can also enable the sorting option for user to just sort on the visual directly, right? But that is like one step further in the manuals of QuickSight. So if you want to show it through controls, which is much easier for user to receive, so you can do it like this way. All right. It seems we are good with questions so far. So now let me move on to another use cases. Before I jump into the following use cases, I want to recap a little bit on the QuickSight evaluation order. This is very important to understand the use cases we are discussing today. So by default, in QuickSight, we're kind of splitting in three different kind of scenarios. So by default, which means we don't consider the level aware aggregation yet. So by default, we are doing we're having a three-stage calculations in QuickSight. So we have a pre-filter level of calculation where by default we're just doing a simple calculation. So the simple what are the simple calculations? It's basically like arithmetic functions. So like doing a plus b or a minus b, or doing some string extraction, data formatting. So those type of calculations are like simple calculations. Once that is done, then we have a level, we call it pre-aggregate level, where we evaluating filters. So notice here we are doing analysis filter and the top bottom filter. So you can imagine like analysis filter is basically like a common where clause, like using that's like directly applied on some columns, right? No matter it's a dimension or it's a measure. Then the top bottom n filter is like the one I showed in the top n use cases, right? Like in this use case. So we will be calculating the measure for that, like was you defined in the top and bottom n filters, and then pick the top ones out of it based on defined sorting order. So this is if we want to do a SQL analysis, this is similar to like a subquery, right? We're in the where clause, and basically you are doing like say the say like teams in the subquery, where in the subquery we're trying to pick the top n of the teams based on certain sorting criteria. And after that, we'll be doing the aggregation and the filters. So aggregation will be, we're trying to aggregate the data from the dataset level to the level we want to display on the visual. And then we'll be calculating the filters. Here now is a post-aggregation filter, so it's mostly like filters that's defined like on top of the aggregate fields. So like the average case use case we were showing before, and it's like applied in the having clause in SQL. Then we have table calculations. So table calculations are the ones to doing like the percentage of total, like default aggregation over, sum over, etc. And then we're trying to calculate the total and subtotals. But notice that the table aggregations here are always after the aggregation. So that's why QuickSight actually introduced the pre-ag level-aware aggregation calculation afterwards. So the level aggregation can be either pre-filter or like pre-aggregation but post-filter, right? So they are basically, I mean, this level-aware aggregation are using like it's a subset of the table calculation that QuickSight offers. It's just that they are calculated at a different calculation stage. So pre-filter will be calculated like after the simple calculation, but before any filter is applied. And pre-aggregation will be calculated after the simple filter is being applied, but before the top filter applied. So there are different stage, basically calculating a different stage of the evaluation process. So yeah, we have a link here which I encourage you to read to get more details about the evaluation order. If you have a better understanding of it, you can use QuickSight you'll be able to understand how QuickSight calculate the visuals and how to leverage it to build some like fancy visuals. Yeah, so with that, let me move on to talk about some additional use cases. So the next use case we want to discuss is called segmentation. Segmentation is a technique that is commonly used in many areas, like market segmentation, right? So where you want to segment your users into different group. And the tricky part here is like one users can be in multiple segments, right? So it's like a M-to-M relationship instead of a one-to-M relationship. So here, what I want to show you is we can like segment different sports into different groups. So we can say that, like say, we have a segment called all sports, which is basically all the sports that's ever played in Olympics. We can also have a team sports, right? So like the big balls. I mean, for example, I just use football, basketball, volleyball, and water polo. And we can have another segment called ball games, right? So in their use case, in here, for the particular items I'm used for examples, I have football, basketball, volleyball, and water polo, and also tennis and golf, right? It's basically all sports with a ball involved. So it looks like it's a kind of a superset of the team sports in here. And then we can have water sports, right? Or sports that where waters are involved as a kind of one like element in the sports. So we have water polo, we have diving, swimming, we have triathlon and sailing. I'll use those as examples here. So how do we segment those sports into this group? What I want to implement is a big vector system for this. So like for each sport, we define like 4-bit vector for it, and 1 indicates that this sport belongs to the segment, and 0 indicates this sport doesn't belong to the segment. So for example, we have football, and also the bit is in reverse order, right? So this is bit 1 for group 1, bit 2 for group 2, bit 3 for group 3, and bit 4 for group 4. So like football belongs to the first 3 groups, but not the fourth water sports, right? So the bit vector for football would be 0, 1, 1, 1, which is number 7 in decimals. Again, water polo belongs to all 4 different kinds of segments. So that's 1, 1, 1, 1, which is 15. Golf is not a water sport, but it's a ball game, and it's of course it's one of the all sports segment. So that gives us a 5. And swimming is 1, 0, 0, 1. It's a water sports and all sports. So that gives us a 9 here. So to define that bit vector, we can define it as a calculate field. So we use sports and segment, and we will just use we'll basically just use if else again, like we seen before, and we kind of manually define the expression and use that to calculate. So if like the sports belong to this category, we'll give it 1 for this bit, and then times its value, right? So the second bit, first bit will be 1, second bit will be 2 times 110, then the third bit will be 4 times 110, and then 8 times 110. So that we added them all together, and we'll get the sports segment. So let me show you that in our calculate field editor. Yeah, here it is. So I think I have, and we can also see the sports segment here in our visual. So I think I have put like a handful of sports here. It's definitely not all the sports that we have in Olympics. I put it here, and I'm also putting a sports segment, the field here. So remember, this is again, this is actually, it looks complicated, right? But it's actually a simple calculation, right? So, or arithmetic calculation. So there's no aggregation involved yet. So we want to specify the sports segment, the aggregation function for it to be max. And then we can say like water polo is 15 as we expected, right? Basketball is 7. Football is should also be 7 as we expected. So now let's find a way to actually filter these sports based on the segment, right? So we can define a parameter. We call it segment selection. It's like this one. So it's again a string based single value parameter, where the default value is all sports. And in the control bit, we allow user to pick from all sports, ball games, team sports, and water sports, basically all the groups in our definition. And then the next thing you probably wonder is, how do we correlate the parameter with the filter and apply that onto the visual, right? So to do that, we need one more additional step. We need a segment indicator, which indicates if this sport belongs to the chosen segment or not, right? So to do that, we have defined the calculate field in 2 steps. So the first one, we have to convert the strings in the parameter into a number, right? So it's straightforward. We just do all sports is 1, team server is 2, both board game is 4, right? Which corresponds to this position in the bit vector. So all sports is last bit, then team sports is the second bit, so that's number 2, and then the ball game will be the third bit, which is number 4, right? So on and so forth. And then we are using a calculation here to find if this sports belong to the particular segment. To do that, we are doing two steps of calculation here. So this is a little bit tricky in math. So we are first doing a division. So we'll divide the sports segment, the number here, by the segment choice. So what it does is we will basically, let me show you it in some calculation here, which is more intuitive. So let's say we have let's use golf for example. So golf is 0, 1, 0, 1. So if our segment choice is 2 here, which is basically the second group, team sports, right? So when we do the division, and it will basically, we can rewrite that into binaries. So that will be 10 in binaries. So we'll do division. So it's going to be 0, 1, 0, 1 divided by 10. That will give us 0.1 in decimal. Okay. And then we're doing a floor here, right? We're doing a floor. It will remove anything that's behind the decimal point. So if you do a floor of it, to remove everything behind the decimal point. And the next step, we're doing a mod function, right? So we're doing a mod of this result by 2. What we'll do is 2 means 10 in binaries. What it will do is it will actually remove anything like before the first digit. It will give us a 0. So literally, I mean, this whole calculation will give us the corresponding value of the particular bit. So when choice is 10, we'll be keeping this bit, right? If the choice is I mean, I should not say 100, 10 or 100. The choice is 10, we're keeping this bit. If the choice is 100, which is the third bit, we'll be looking at first, let's do it one step by step. So first, divided by 100, we'll get 01.01, right? With a floor, we'll get 001. And with another mod, we'll be getting 1, which is basically this bit. So this is just a calculation doing something more like a bit end. We don't have that function in QuickSight, but we are kind of finding a workaround with floors division, with division, floor, and mod. And with that, you can see that with segment indicator, we're getting 1 or 0, right? And if we choose between different sports here, let's say if you do ball games. So basketball is ball game, right? Which is 1. Diving is not, which is 0. So on and so forth. And then like water games, water sports. Again, basketball is not, so indicator is 0, right? And dimension diving is, so which indicator is 1. So with that, I mean, we kind of achieved our goal here to have basically a segmentation and also indicator to indicate if sports belongs to segmentation or not. So now we can basically using this indicator as a filter, right? Using a filter, again, we don't want to apply aggregation to it because this is a all calculate pre-filter, pre-aggregation. So we just do segment indicator lower aggregation equal to 1, and then you can use it to filter this particular visual. And now we're showing all sports, and now we're showing like ball games. Here we are doing a count of distinct teams, just show how many teams who actually participate in this particular sports. Like now team sports and water sports. You can see the different results. Okay. Yeah, so that's the use case of segmentation. And now let's move on to talk about a little bit more on a use case of level-aware aggregation. So in this use case, the question we want to ask is, what is the chance to win a medal in Olympics? And some follow-up question would be like, what is the chance to win a medal by sports in Olympics? And then what is the average chance to win a medal in Olympics across sports, right? You can see the first question and the last question is similar, but the calculation logic can be different, right? So like the first question is like, we're basically trying to we find all the people who ever win a medal and divide up all the participants who ever win a medal, and then divide the number of participants in the history of Olympics. But the third question would be actually a follow-up of a second question. So in the second question, we try to calculate the similar win chance by Olympics, by sports, and then we are trying to calculate the average over that, right? So this is a typical type of nested aggregation in our use case. So to do that, let's first, we can show how to calculate the first question. We are just doing a chance of a medal, and its definition, it should be relatively straightforward, right? So we are doing a count if over medal when the medal equals to gold or silver or bronze, right? Then divide that by the total number of records in the history. So that is straightforward, and we just put that into a KPI visual, and we show that it's 14%. That's not too bad. And then we can do the same thing to calculate the chance of medal by sports. And I mean, it's interesting to see that actually some of the sports actually has 100% of medal chance. I think, especially like I think I look into it, like for example, like lacrosse. Like every team who participates in lacrosse actually will win a medal. It's probably just for the first. It's like lacrosse is only Olympics for the 2 times, 1904 and 1906, right? I guess just 3 teams participate, and they all win medals. Yeah. So now let's think about the third question. That'll be a tricky part. So now you can see that some sports actually has a really high winning chance, right? Like lacrosse and the cricket, etc. So when we do the average over these measures, this output, I mean, you can expect that the number will be slightly higher. So to do that, we want to use our level-aware aggregation. The reason being is in QuickSight we don't support nested aggregation yet, so we have to first calculate the winning chance by sports, and we have to calculate that using like level-aware aggregation functions, and to calculate at the dataset level. And then of course there will be some duplicate rows, right? So to do that, we will need to aggregate from the column with duplicate rows, and then we use some technique to remove those duplicate rows from the calculation. Yeah, so here is some math as we derive this calculate fields that we will use in this example. So think about it like the average chance across sports, right? It's basically the winning chance by sports. We take a sum of it, we calculate the sum of all the winning chance, and then we divide by number of sports, right? So this is very straightforward. And now to calculate the winning chance by sports, inside the sum, we're basically calculating the total wins by sports, right? Total number of wins by sports and the total participant by sports. We do a division of that and then calculate the sum and then divide by the number of sports. So then we try to convert this formula or expression. We want to connect that with the level area aggregation we can do. So the total wins, I mean, it's actually easy, right? So the total wins is basically the total wins. We can do a win count, right? We're using level area aggregation. And the total participant by sports is also easy, right? We're just doing a participant count using level area aggregation. The output we set it at the sports level. Same here, the output will be at the sports level. So the only tricky part is we will be having duplicate rows because our output will be at a sports level and it's going to be repeating for all the record in your data set per that sports, right? So think about it when we're doing a sum of the repeated record, like for each sports, like if there's 10,000 record for one sport, when we calculate this and after that we calculate sum, we are basically calculating this value like 10,000 times, right? So to offset that, I mean, we just need to divide the rare value by 10,000 and then do the sum, right? It's like we aggregate them all together, but it's duplicate, so we divide by 10,000, right? But we can just put in, I mean, it's a plus and a division, right? So we can divide first and then plus. Doing this, why we're doing this is because like for each sports, we may have different counts, different duplicate counts. So that's why we want to divide by this count first, so that it's applied at the record based. And for each record, if it's belong to a different sports, then it's kind of divided by different count. And with that, we'll be able to calculate the sum, the actual sum of the total winning chance, and then we divide by number of sports again. So basically we only need 1 and 2 and I think 3 calculate field and then another calculate field to put them all together. So let me show you that. So I will first show you the winning count, LAA. So we are doing inside we are doing a if else, right? So if it's medal, then we are giving the value to be 1, otherwise 0, right? And then again, remember this is a simple calculation and it's applied, I mean, for the first step in our calculation stage. Then we're doing a sum over of this simple output of a simple calculation of the if else. And we set it to be at sport level with pre-ag. So that's our win count. And similarly, we have our participant count. We just sum over 1 and output that to sports level. And then you can see that for win count and sports count, we want to set the aggregation function here when we show it to be minimal, right? Because our repeated number of rows, if we do a sum, here you can see that it basically gets like the numbers will be quadrat. The number here showing here will be like in the power of 2. So let me show you. So you can see that let's say basque pelota now is 2 and 2, right? So if we change that to a sum, you'll be seeing like 4s here, right? Because the winning count is 2 and the participant count is 2 for the sports, and there are 2 records, right? So when you do 2 plus 2, you will get 4. And if a 3 record, it will be 3 plus 3 plus 3, which is like 3 to the power of 3, so you get 9 here. So let me change it back to minimum. So I'm just trying to show you like how how this thing is calculated when with aggregation function, so you have a better understanding of it. So now with this 2 counts, we can calculate, we can define our average win across sports. Let me show you the formula of it. So like how we derived the formula in the expressions. So we're doing sum of the winning count divided by participant count and divided by participant count again, right? And after all the 2 divisions, we're doing sum, and then we divide that by the number of sports. So based on our mass derivation, we can expect the result to be correct. So you can see that in this case, we are calculating, I have enabled total bit. And you can see that for the last column, which is average win chance across sports, you can see the lower ones are the winning chance per sports, and the total we are seeing the average across all these different sports. And it's gonna be same here. We can put that into a KPI, and if you compare it with the total chance of winning medals, is gonna be much higher because we have some sports that have like higher winning chance than others. So the data is kind of a little bit screwed when we do calculation this way. But it's very different. But it's a different perspective when we view the winning chances in Olympics. Yeah. So I mean, yeah, like Ian said, this is this example, like showing you how to use a technique. We do have some real use cases in from our like experience of the QuickSight practice. We have seen people want to do very similar calculation in this, like doing like say doing a KPI tracking for a company, right? So we have different pillars of the KPI, and we want to calculate kind of an average or totals of the KPIs. So that'll be good, very helpful when you have such use cases. And now, if no question here, now let me show you the next use case, which is a set qualification, like a single selection set of qualification. So the business use case or the question here, business question here is what is team like who participate in football? What other sports the team actually played? So let's first look at the output. I mean the result of this use case. I mean you can see it's very fun. Users can select sports here. By default is football, and you can select from a list of sports, and it will show you what like for this teams who played in, let's say in golf, what other sports this team also played, and the sports are sorted by the number of teams that's actually ever participate in the sports. So the logic is a little bit tricky here, right? So because we are looking at one sports, and we are looking at the teams who play the sports. Then we're looking at the other sports these teams actually played, right? So it's a like two-step jump in a logic, and we call it a set of qualification, and sometimes it's also called, like for this particular use case, it can be also called collaborative filtering, right? So it's kind of find the correlations between like sports. Yes, like if you are familiar with like recommendation engine, like you can see that this we are trying to looking for particular sports, what are the similar sports this sports is, right? So in this use case, how do we build it? Like of course we cannot. I mean, it's probably very obvious to see that we cannot just apply the sports filter on top of visual for it, right? Because if we say, let's go back to the default value, which is football or soccer. Like if we apply a direct filter on like sports equals to football, you will be getting basically you will remove all the like record in this data set that's not football, right? Then there's no way for us to calculate other sports this team played. So to achieve that goal, I mean, think like we're actually looking for teams instead of like the sports being football. So we're looking at the use we can leverage is the top filter that we have seen earlier, right? We can say top teams who actually participate in football. So the definition of that is actually in the filter. So we first create the distinct count of the sports. Let me show you that, which is the calculate field. Sorry, let me take one step back. Of course, we first want to create a parameter of sports, right? So it's going to be a string parameter, which default to be football, and then we can create a control for it, which is now we can link it to the Olympic data sets and to the sports field, right? So we will get all the sports available in this data set. And for the second step, we want to define a calculate field. That's more of an indicator, like distinct countif on sport. So if the sport equals to the 1 in selecting the parameter, we are counting that, and we're counting that particular sport, and it's going to be a distinct count. So why we use distinct count? Because like a team may participate in this sport multiple times, right? They may have multiple players. So with distinct count, we are only getting 1 if the team is ever participating in the sport. So come back to here. We don't have a filter yet, so we just put teams and this particular this calculate field on this field on the visual, and you can see that for like say now it's football we're chosen in the control. So you can basically see all the teams who has ever played in football will get 1, which is an indicator for the team being played in the football, right? For the teams that's never played in football in Olympics, they will get 0, right? So now we have an indicator for team playing in football, and the next step is move to right. Again, we have team and sports, and we can from starting we can define the sports. Sorry, we can define top filter on team, and what we'll do that is we'll just use the team and the top and bottom filter with top 1 and sorted by the distinct countif of the selected sports, right? So this met the calculate field we just defined. Notice that we don't add a tiebreak here, so that it will not give us just 1 record because there's no tiebreaker. It will give us all the record that has that actually has ever played in football, right? So basically, it will give us all the teams that has ever played in football. So with that, you can see that for Afghanistan, like this is a country that has ever played in football, right? So for this particular record, for this, then they also participate in 1, 2, 3, 4, 5, 6, 7 different sports, right? And now we can also define another filter, another calculate field of count disk teams. Count disk teams to find like how many teams are there for this group of record, team and sports combination. So you can see for this combination we have 1 team, And we can still use the distinct countif of select sports, this calculate field here. So we can say that for this group of record, after the top filter for football, so this only football has a distinct countif, right? So on football, of course. So that's why this row returns a 1. Others are going to be 0. So with that, we can actually remove because we eventually want to reporting on sports, like what other sports those teams ever played, right? So with that, if we can remove the teams from the visual, and we will be only seeing sports. So let me show that from here. If we just remove the team from it, and I can sort by the number of teams. And you can see that, I mean, you can see basically now seeing all the sports that's played by the countries who ever play football. And of course, football will be the top of the list because we only have like every country is in the every team in this list will be playing football, right? So how do we remove this first record? So, I mean, you could already see that it's on the right-hand side. So distinct count of select sports will be only 1 for football, and for all the other sports, it's going to be 0 because they are not football, right? So you can add that filter. Let me come back here. So that will give us the third visual where we have the sports and the distinct count on teams, and we have the top filter, and we also add another filter says the distinct count of select sports equal to 0. Yeah, so with that, we'll be able to see like what other sports the team also participate in other than football, right? For all the teams who participate in football, what are all other sports they also participate in? All right, so it seems we are doing good on questions. With that, I will hand it over to Yin to cover the rest of use cases.
Yep, thank you, Ian. A very good presentation. Yeah.
Let me change you to presenter.
Yep, let me get this. And let me know if you're able to see my screen.
Yes, I can see your screen.
Okay. Yep, great. Yep, thank you very much, Ian. Make a very good presentation. So after the set qualification explanation, you might have a following up question. How about if I would like to select multiple sports? Like I don't want to only know the team who play football. I would like to know the team who play football or basketball. And I would like to make it more complicated. I would like to know the team who play football or basketball, and they play badminton or archery. So I would like to have multiple selection choice. And at the same time, I would like to add some complicated and or operator for my choice. One very common use case is I would like to select a sports from the sports selection 1. Be careful, by default, any selection here in the filter, it's similar like the in list, similar like all. So I would like to get the sports list in one of these, and I would like to get the sports in any one of these selection. And I use the AND operator to combine the two selection together. How could I do that? Let me give an example. So for example, here, I would like to Yeah, you might want to close the analysis from your side. Yeah, that's one problem. If two people open the same analysis together, then we will see this problem. So, for example, if I select badminton here, and I select table tennis here, and I know all those teams. Forget about the empty string. I put here to remove those garbage data. So I will know those teams, those countries, they play either badminton, either table tennis. So I choose Chinese Taipei, Germany, India, Indonesia, and PRC. And I know those 5 countries, they play either badminton or table tennis. And then I make a selection here. Let me choose like services and boxing, for example. So now the team display here, the country display here, they play badminton and athletic, or badminton and boxing, table tennis and athletics, or table tennis and boxing, 4 combination. So they pick up one element from here, one element from here, and add them together. So we can construct the filter in this way. How could we do that? What we can do is, firstly, from the set qualification section Ian just conduct, you will understand we cannot directly apply the selection on this visualization. If we apply it, then we only display the data for badminton and table tennis. Whatever selection we make here, actually, we use AND condition to combine them together, but actually in back end of QuickSight, what they are doing is they apply this selection and then they apply this selection after we apply this selection. So you will see no data return. So how can we do that to really make this AND happen? What we do is very simple. You see here? I put the visualization 1 on the back, and I let the sports selection 1 target on this visualization. Okay? And then I created the visualization 2, which is the one I really would like to display the team for you on top of it. And I make this one on top of it. You can say send to back, send to backward, bring forward, bring to front. So I created 2 visualizations, but I allow this one on the top of the one in the back. So this one is the one I would like to display to you. And at the same time, in this filter, what I put is I put the team here, but I make the team to be controlled by the sport selection 1. That's the cascading filter. So whatever selection I make in the sport selection 1, it will restrict the element in the filter 2 for the team. Okay, so the element filter by the sport selection 1. And then I let the team filter target on this visualization. I only let the team filter target on this visualization. So whatever selection I made here, it will only display the selection I choose here. And then I created the sport selection 2. And the sport selection 2 is an AND condition with the team selection. So in the sport selection 2, I choose anything and I apply to this visualization, then it means any team, they also play one of the sports in the sports selection 2, then we display here. And now let's do it further. How about I would like to know all the sports those teams play? you can make this visualization to do an action. And the action say, hey, I do the filter on teen, and I do the activation as I click it, just select. Menu means right mouse click it. And I do the filter action. And what's the filter scope? I'm using teen to apply the filter. And the target VSU, this is the one VSU 3. So if I click Germany, and this selection action will push down to VSU 3. Now VSU 3 only display the country, the teen Germany, and I display all the sports of Germany. That's the set qualification we achieve by using these two visualization, by push down the filter into the parent visualization to target on the children visualization to achieve it. And you can see, yeah, Germany play the table tennis and athletics. So table tennis and athletics, one choice of the 4 combination, and that's all the sports Germany attend. Okay, so this one is for the complicated, comprehensive set qualification with the combination of different filter with the and or operator together. And I see in the attendee that some of our friends from 3M, we generate this case actually for 3M. They raise this question to us. They throw this headache to us. So we work on it to resolve this problem for our friends in 3M. And if you use MicroStrategy or Cognos in your previous project, you will understand there's a very common question, a very common use case for those enterprise BI usage. And another one is a kind of like a bonus. For example, I don't want to do so complicated. I don't want to do that. I don't want to do the and or combine together the set qualification. What I would like to do is very simple. I just would like to do in this filter, what I choose is not like a in list. It's not like a this one or this one. I would like to do this one and this one. I choose some of the sports. Which team play archery and athletics and badminton, for example. So how could we do that? Let me choose here, let me choose here, and let me choose here. So only Japan, this team, this country, they play archery and athletics and badminton. So if you would like to validate data, click it. And here I show you the valid data. Yeah, Japan play archery and athletics and badminton. And let me go back to here. So how could we do this AND case? Yes, it's very simple. So in here, we create a field called count sports per team. We use the window function as Ian explained in the LAA use case. We do the distinct count over. So we count distinct the sports. Sports actually in data sets, they call it discipline. Don't worry about that. And count on what level? We count on country level, count on team level. And what evaluation order? Pre-aggregation. Pre-aggregation means we do the group by in the visualization level. We do the calculation in the dataset level directly. And we create another calculation field. And this calculation field, it is count sports on total level. If here you put it as empty, that means just count the sports on total level. and also pre-aggregation. And now we create a third one. I named it as new team. Team for AND operator. So if count spots on total level equal to count spots on team level, then we display the corresponding country. Otherwise, we say not available. Doesn't meet the condition. So you can imagine that if a team, they play all the sports with AND operator together, like Japan, they play the 3 sports indeed. So count sports per team equal to 3 for Japan. And at the same time, I count the sports on total, of course, equal to 3. Then Japan meets the condition. But for the other country, because they don't play those 3 sports at the same time, so when we do the count sports per team, when we make the selection, they will equal to 2 or equal to 1 or equal to 0. So this condition cannot be satisfied, so that they will display not available for that country. And then in here, I just add a filter, say, exclude any not available country, then we can get the country, we can get a team who satisfy play archery and aesthetics and badminton. So the steps here, or the expression of the metric I put here. If you open the public accessible dashboard, you can copy the metric formula and try by yourself. Okay, so far so good. Any question? Yeah, Ian can answer the question for me if you have any question. Just feel free to post it in the question section. And now let's have more fun of security filter. The security filter in QuickSight, we name it row level security rules, and we also call them RLS. That's the initiation of the row level security. And it's similar as the other BI application when they say security filter. So security filter is when you log in with a specific username, when you log in with the user belong to a specific group, then you can see the data assigned to a user or the data assigned to the group you are belonging to. So first thing first, you have to register the user. You can do it from the UI. You can also do it from the API. Here I provide an example. You call the CLI API to do AWS QuickSight register user, and then dash the input parameter username. What's the username? The identity type. You are using QuickSight to do the authentication, or you are using IAM to do the authentication if you are using SAML row, for example. And you provide the user email so that the user can receive the email to accept your invitation or not. And the user role is reader, author, or admin. And account ID, you are registering this user. And the namespace, you are registering this user. And then you can create the user. And create a group. Currently, group only available to be managed, to be created from CLI. But by the end of November, you should be able to do the group management from UI. But for now, it's only available from CLI. So that's why in the beginning, when Gio say the option pre-request, which is the CLI access, is for this case. If you would like to create a group, you have to use the CLI. So for example, you create a group for everyone who can view the dashboard. So you create a group, let's say Olympic, include everyone. Everyone I add as a member of this group, so they are able to view the dashboard. And then I create a special group, say USA coach. So I make the group name to be volleyball, and that's the volleyball coach. And I create a group for judge. So for example, I create a group called diving judge. So any technical official belong to the Olympic game, they are doing the diving judge will belong to this group. And once we have the user group ready, how could we assign row-level security? Let me open this one. Usually in the tutorial of QuickSight web page, is using a simple CSV file to display the functionality to you. That's easy to understand, that's simple. But in the real world case, in your real business case, you might have to use SQL query to build the row-level security dataset. You have to get data from your data warehouse, or maybe from your LDAP user repository. You map them as a table, and then you join them together to generate your row-level security case. And for row-level security case, there are two very important columns, one called group name, one called username. And you can also use the group ARN or user ARN, whatever is fine. So group name means anyone belong to this group, they are able to see the corresponding data belong to this group. So you can see here, we don't have any specific username put here. So that means any user belong to this group, they are able to see these sports, and they are able to see any records belong to this functional technical officer, jury member. And if one row has both group and user, then what we do is the combination. So these user, they are able to see the USA and the sports and this specific coach, the data. And for the other columns, they are not. That means we don't apply any limitation. But for the other columns, you can see all the data. As long as the country equal to USA, the sports equal to baseball, softball, and the coaching name equal to this one, then all the other column, you can see all the data. And now, how about the group? Because the user level has more specific information than the group level. So for now, even if you define the group and those users belong to this group, but this condition actually it is ignored. We only respect the username information. How about if you separate the group name and username into two different rows, like Carlos Carroll? You have his own user level, row level security, and you create another row only for the baseball, softball, but you don't put any username here. And you allow this user belong to this group. Then for the separated row, it will be an all condition. So this user can see the permission belong to his username or the permission assigned to the group he is belong to. That's the logic of the row-level security. So in here, I use a SQL query to construct the way in that one. The first part is for the judge group. Actually, it's for all the technical officials. You might have the not only the judge, you might have the jury member and some other technical official. But here, let's use judge as the example. So in here, I created the group name by using the sports concatenated with the function. So diving dash judge is the group name. And I don't put any username here. So any user belong to this specific group, they are able to see the data. What kind of data? All the country, because country I put not here. And the specific discipline, for example, diving, right? And what function? Judge right? And any records, any coach name, any player name, any technical official name, anything this group member can see, as long as it is diving and judge event. Okay. And here, the second one is for the coach. For coach, I try to display the use case. How about there's a row. In this row, we define both group name and user name in the same row. What will happen? So I put the coach sports, the coach discipline as a group name. Like for example, baseball, softball, basketball, whatever. And then I put the coach name as the username. And then, so here, what they can see is they have to respect to the country they belong to. They have to respect the sports they are coaching. But they can see anything meet any functional technical official belong to those conditions. And they respect the coach name. So the coach only can view the events belong to he or she. It is the coach for those events. But he or she can see any player, any technical official belong to the events. He or she is the coach. And here, because as I explained, the group and username define the same role, and obviously the coach username is one-to-one relation to the coach name itself. So the coach name take the more granular security. So we respect the coach name and forget about this one. This one cannot raise up the security limitation for the specific coach. No way. If you would like to do that, you have to separate into two rows. So let the user has the username permission or the group name permission in another row and make the username to be null to do that. And the third one is the most restricted one. I don't assign any group. I only use the username. That's for all the player. For all the player, log in with the player name as the username, and then this player can see all the events he or she is playing in. Okay, but whatever coach, whatever technical official, whatever the function of the technical official, this player can see all the events this player play into. Then of course, the country and the sports apply here. And here you might see some special backdoor I'm making. So the admin group, this one is my name. Don't worry about the Isengard or whatever. That's an internal usage, but this one is myself. So for myself, I don't say any group. I just use my username, but I put everything to be null here. That means I can see everything in the dataset. And similarly, I give Ian, I give Guinea the permission to see the data. And similarly, I put the demo user in the information here to see everything here. So now let me give you a more detailed sample data for you to understand more. For example, Quan Hongchan, she is a player in diving in China. So you can imagine that when she logged in with her username here, as I define, this user is only able to see all the events belong to this player name. And the player name is lower level than the country, than the sports. So it's already predefined. Only the events belong to this player. These two, they are parent of player name. So don't worry about that. And if, so let me show you here. So now this user Chen Hongchan log in to the dashboard. So in the dashboard, what she can see is only the events related to this player name. And for the technical official, yeah, any event she play in, if there's a technical official there, then we display all the technical official for her, because all the technical official relate to her event. And there's no any coach information for the diving events she is playing in. So the coach information, it is no data. And you might curious what's happened in the historic, because in here I make a specific data sets for 2021. All those 3 received, they are from 2021. And here, this one is the historical data, because Chen Hongchan is brand new in 2021 Olympic game. So there's no data for her to view in the historic events. And now let's go back to here. How about I would like to see the diving judge group, what happened. So any user belong to diving judge group, this user is able to see all the events belong to diving and judge. And I know Guo Jingjing, she is a diving judge. So for Guo Jingjing, this user, she should be able to see all the events related to diving and judge. And in the historical records, she played Olympic game before. So she should be able to see the historical events of the Olympic game. I apply the filter here. Let me show you here. If I log out Chen Hongchan, and then I log in as Guo Jingjing, and I put the password here. No, what's going on? I put the password here, and then log in. So Guo Jingjing belongs to the everyone group. So she's able to view this dashboard. And when I open it, and you can see Guo Jingjing can see all the diving sports, all the events belong to the judge. She is a diving judge. And again, because diving events, we don't have the coach information, so no data return. And in the historical event, she was a player. So from 1996 to 2008, she was a player. So she's able to view her player event. So far, so good, right? And a furthermore case for the coach. So you can see for this coach, he's a volleyball coach. And his records is here. For his username, he's able to see any coach event he running for volleyball and USA. And he also belongs to the volleyball group. But again, as I described, because we put the username and group name and the same row and the same line. So we respect the more granular level, which is his permission of his username. If we would like he to see not only his username, but also the volleyball group permission, then you have to separate this guy into 2 rows. One is the username permission, and another one you can construct the volleyball, but without the specific username. Then he's able to see his event or all the volleyball group events. But for now, I put them into the same row, so more granular level, he's only able to see the data belong to his coach event, USA volleyball. So now let's take a look here. If we sign out Guo Jingjing, and then we log in here, and we use the same password. Just make the password to be same, and then log in. And then you can see he's able to see all his coaching events. And he's able to see all the functional tech officer event belong to his coaching event, right? Some referee and some other judge information. And he's able to see in the coach datasets all the coach information belong to him. And he never attend the historic Olympic game as a player, so no data written for historical records for this coach. So that's everything about the security filter. So far, so good. Feel free to post your question in the question section. And now let's move to the advanced calculation. That one I will not display. I will not demo the source code because it's too long. It is more than 200 rows, so I will not display that. This one is from a public accessible project from Chan Zuckerberg BioHub. I delivered more than 1 year ago. And here, if you click it, you can see the public dashboard Chan Zuckerberg BioHub released to the public audience. They are using the COVID-19 data to do some forecasting. And they have the data on country level, state level, and county level. And when you do any forecasting, you have to design your algorithm, your modeling. But for any modeling, there are two very important parameters. They call it K and K1. The K and K1, they calculate the last 5 day confirmed case and death case steadily. So you have to take the last 5 value from those cases, and you calculate these 5 value as an array and use NumPy, use pandas to do the data cleaning, use NumPy to do the calculation. First you get the log, and then you get the first degree gradient and get the mean for the K. So here you put the confirmed case, then you get the K of confirmed case. And if you use the second degree gradient, you get the confirmed case, the K1 of confirmed case. And similarly for the death case. So here is the requirement from Chan Zuckerberg BioHub. They have their own data source, and they would like to combine with the public data lake we deliver to all over the world, or the public audience. And they would like to study the USA data on state level and county level. And they would like to display some daily trend, and they would like to do some normalization, and they will display both normalization and non-normalization data. Normalization just means you divide the case number by the local population. And they would like to do the calculation on the K and K1. And for the detailed forecasting model, they don't share to the public. But for the K and K1, they would like to share to public in this public dashboard. So how can we do that? Of course, we can use SageMaker integration, but for K and K1, because they only do the daily data refresh. And this one is very simple by using NumPy and Panda. Not very simple. QuickSight cannot handle it, but we don't have to do the K and K1 calculation by using SageMaker because you don't need the near lifetime data inference, and you don't need a very complicated pre-built data modeling. You know the formula. You already know the formula, and you are doing daily refresh. So what I designed for them is, okay, you get the data from the GitHub repo, Chan Zuckerberg BioHub. They host the data there. And then I create a glue job to do the daily crawler to crawl the data from the GitHub, and then save them into S3 bucket. And then I combine with some other data from the AWS COVID-19 public data lake. And then I created the Athena table based on those S3 data. And then I create another glue job. In that glue job, I utilize pandas and NumPy library to perform those calculations. And then I save the calculation results into another folder of the same S3 bucket. And then I also created a Athena table based on the data because the schema already know. I already know the schema, state level, county level, K and K1. But the only thing is every day the data will be changed. So I can pre-configure the Athena table based on the already understand schema, but the data will be refreshed every day. And then I build a QuickSight dashboard based on those Athena table to demo the data to the public. And then for any private data modeling to do the forecasting based on the K and K1 and some other information, we use SageMaker to calculate the forecasting and the anomaly detection. And then we integrate SageMaker with QuickSight to demonstrate everything. And I believe Aaron or some other solution architecture, they already demo to you how to do the SageMaker integration. Combine with that workshop together, you can build the structure in this way. So this one, you can achieve everything you want, but with the lowest cost. Glue is much cheaper than using SageMaker if you only would like to do the daily data processing and you don't need a pre-built model, you don't need a so complicated model. You know you are able to do the calculation by using those Python library. So that's it. And if you would like to take a look, it's here. And they already stored the data refresh by the end of last year. So here it is the final results. You can see here the K and K1 and the log case and the detailed K and K1 information here. And of course, you see 0 now because they store the data feeding after December 31, 2020. We are only used last 5 days to do the calculation. And that's it. Thank you very much. And thank you very much for spending the time with us today. And here is the feedback. Yep, thank you very much. Yep, enjoy the beauty of QuickSight.